Assalamualaikum. My name is Noris Azari bin Israel. Together with my friends Abdul Rahman bin Musa and Aidar Ali bin Rasul. We are from Brunei. Today we will be presenting our topic entitled Comparative Analysis of Laser Light and Infralight and their roles in medical equipment. This presentation provides a comparative study of laser light and infralight, focusing on their characteristics, operating principles, applications, and significance in modern medical equipment. We begin by discussing the historical development and fundamental properties of both types of electromagnetic radiation. We then compare their key characteristics, where laser light is known for its coherent monochromaticity and high precision, while infralight is associated with longer wavelengths and heat detection capabilities. In addition, this presentation highlights the use of laser and infrared technologies in various medical applications, including surgery, ophthalmology, dentistry, thermal imaging, patient monitoring, and diagnosis systems. Overall, both laser light and infralight play important roles in advancing healthcare technology by improving the accuracy, efficiency, and safety of modern medical equipment. Before discussing laser light and infralight, it's important to understand electromagnetic radiation. Electromagnetic radiation is a form of energy that travels through space as electromagnetic wave. The electromagnetic spectrum consists of several regions, including radio wave, microwave, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. As shown in Figure 1, both laser light and infralight are part of the electromagnetic spectrum. Although they belong to the same spectrum, they possess different properties that enable a wide range of scientific, technological, and medical applications. Understanding their positions within the electromagnetic spectrum helps explain their unique functions and uses. Laser light and infralight are two forms of electromagnetic radiation that possess distinct characteristics and applications. Laser light is produced through stimulated emission and is highly focused, coherent, and monochromatic. These properties allow laser light to deliver energy with high precision, making it useful in various scientific and technological applications. In contrast, infralight has wavelength that longer than visible light and is commonly associated with heat detection and thermal imaging. As shown in Figure 2 and Figure 3, laser light and infralight have unique properties that make them suitable for different purposes. These characteristics have contributed to their widespread use in modern technology and healthcare. The unique properties of laser and infralight have made them highly valuable in modern healthcare. Laser light is widely used in surgical procedures, ophthalmology, dermatology, and cancer treatment because it can deliver energy with high precision and accuracy. On the other hand, infralight is commonly used in patient monitoring, thermal imaging, and non-invasive diagnostic systems. As shown in Figure 4, both technologies are integrated into various medical devices and play important roles in improving the effectiveness and safety of healthcare services. Their applications have significantly contributed to advancements in modern medical equipment and patient care. Having introduced the basic concepts and medical importance of laser light and infralight, in the next section we discuss the historical development and operating principle.
The history of laser light started with Einstein's stimulated emission theory at 60-70. It wasn't until 60s that Cedera Maiman put the first working laser using UV crystal at 694.3 nanometers. In the 60s and 70s, various lasers like helium neon and carbon dioxide were developed. Medical application began with retinal photogradation in the 60s, and by the 70s, carbon dioxide laser became the standard for surgery. Figure 5 illustrates the key milestone from Einstein theory to modern medical lasers used in surgery and dermatology. Infrared light were discovered in the 1800s by William Herschel using a prism and thermometers. Early infrared detectors were made by thermocouples and bolometers. Military needs during World War II to drove the development of night vision system. After the war, technology advanced to photovoltaic detectors in 1950s and cryogenic MCT detectors in 1960s and focal plate arrays in 1970s. Today, the infrared is used in medical thermology and pulse oximetry. Laser light operates on the principle of stimulated emission, where an incoming photon triggers an excited atom to emit an identical photon. This requires population inversion. Laser light has four characteristics, which is coherence, monochromaticity, directionality, and also high intensity. The working principle involves absorption, spontaneous emission, and also stimulated emission. The diagram on this slide illustrates this process and characteristic. Infrared light has a wavelength range from 700 nanometers to 1 millimeters. It is divided into near, short wave, mid wave, and also long range infrared. According to Planck's law, all objects above the absolute temperature emits the infrared radiation, with intensity varies and depending on the temperature. In biological tissue, water absorbs strongly in mid-wave infrared, while hemoglobin and melanin absorbs near infrared. Figure 7 shows the electromagnetic spectrum highlighting the infrared region and medical application. A laser system has 4 essential components. Firstly, the laser medium, which can be solid, liquid, gas or semiconductor. Secondly, the pump source, which used to supply energy to create population inversion. Third, a highly reflective mirrors that used to reflect near 100% of light. Fourth, an output coupler that transmits near 50 to 99% of light. Figure 8 shows how this component works together to produce a coherent output beam. An infrared system consists of 3 main components. First, the infrared source, which can be hot filaments, LEDs, and infrared lasers. Second, the infrared detectors. Thermal detectors include thermocoils and bolometers, while photon detectors include photodiodes and TWIPs. Photon detectors are faster but require more cooling. Third, the signal processor, which used to amplify and filter the signals. It shows the flow from the infrared source to the receiver by acting as a detector and finally reach as the output signal. Finally, here are 3 medical equipment examples. First, an oxygen surgical laser system. The internal laser cavity generates an infrared beams to be delivered to the articulated arm to be cut and coagulates the tissue. Second, a pulse oximeter, which uses red and near-infrared LEDs to measure the blood oxygen saturation. Third, an infrared thermometer, which uses thermocoil sensor to measure the body temperature from thermal radiation. Figure 10 shows each of these devices.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Rahman bin Musa and I'm going to continue the presentation with meaning of terms. First, we go to meaning of laser light. Definition of laser light is a type of electromagnetic radiation generated through the process of stimulated emission, in which the excited atoms release photons that are amplified to produce a concentrated beam of light. The term laser stands for light amplification by stimulated emission of radiation. Next is characteristics of laser light. Firstly, it is monochromatic. It means it consists of a single wavelength or color. Secondly, it is coherent. The light waves maintain a constant phase relationship with one another. Thirdly, it is highly directional. It travels in a narrow beam with very little divergence. And lastly, it has high intensity. It concentrates a large amount of energy into a small area. And this figure, it shows how 3 types of light wave behave. First, we go to sun. Sunlight behave like it has many frequencies, different colors, and non-coherent. Secondly, we have LED light. LED, we know that it has 1 frequency, 1 color, and still non-coherent. And for laser light, it is 1 frequency, 1 color, and it is coherent. Next, we go to infrared light. Meaning of infrared light, infrared light is a form of electromagnetic radiation with wavelengths longer than visible light and shorter than microwaves. Typically, it ranges from 700 nanometer to 1 millimeter. Although invisible to the naked human eye, infrared radiation is commonly perceived as heat because it is emitted by warm objects. Next, we have characteristics. Characteristics of infrared light, it is invisible radiation. It cannot be detected by the human eye. Next, it has longer wavelength. It ranges from approximately 700 nanometer to 1 millimeter. Next, it has heat emission. It produced by objects according to their temperature. And lastly, it is non-ionizing radiation. It does not possess sufficient energy to ionize atoms or molecules. And this figure shows position of infrared radiation within the electromagnetic spectrum, illustrating its wavelength range and classification into near, medium, and infrared regions. Next, we go to the comparison of between laser light and infrared light. In terms of definition, laser light produced by stimulated emission of radiation, while infrared light it is electromagnetic radiation with wavelengths longer than the visible light and shorter than microwaves. In terms of their wavelength range, laser light can range from ultraviolet to infrared depending on the laser type. Infrared approximately 700 nanometer to 1 millimeter. In terms of coherence, laser light coherence, light waves are synchronized and in phase, while infrared light generally non-coherent. Waves are not synchronized. For directionality, laser light is highly directional and focused into a narrow beam, while infrared light it radiates in multiple directions from a source. For its monochromaticity, laser light is usually monochromatic, consisting of a single wavelength, while infrared light contains a broad range of wavelengths. For energy concentration, laser light has high energy density concentrated in a small area, while infrared light has lower energy density spread over a larger area. And lastly, for medical application, laser light can applicate into LASIK surgery, tissue ablation, dental procedures, and cancer treatment. While for infrared light, it is useful in temperature measurement, pulse oximetry, thermal imaging, and physiotherapy. And the source for this table is we get adapted from Height 2017, Silvas 2004, and Webster 2009.
After understanding the basic principles of laser light, we can now examine its applications in medicine. Laser light is widely used in healthcare because of its high precision, controllable energy delivery, and minimal invasiveness. As shown in Figure 13, laser light technology has many important medical applications. In ophthalmology, lasers are used in LASIK surgery to correct vision problems. In surgery, lasers can cut or remove tissues with high accuracy while minimizing damage to surrounding areas. Laser technology is also used in dentistry for procedures involving teeth and gums, as well as in terminology for skin treatments and cosmetic procedures. These applications have improved treatment accuracy, reduced recovery time, and enhanced patient outcomes. Besides laser technology, infralight also plays an important role in modern healthcare. Infralight is widely used because it enables non-invasive monitoring, diagnosis, and therapeutic applications without causing discomfort to patients. As shown in Figure 14, infrared technology is commonly used in pulse oximeters, infrared thermometers, thermal imaging system, and physiotherapy devices. Pulse oximeters use infrared light to measure blood oxygen saturation levels, while infrared thermometers provide rapid and contactless temperature measurements. Thermal imaging systems help detect abnormal temperature distributions in the body, and infrared physiotherapy devices are used to support pain relief in rehabilitation treatments. These applications allow healthcare professionals to monitor patient conditions safely, efficiently, and in real time. After discussing the individual applications of laser and infralight, Table 2 summarizes the main differences between these two technologies in healthcare. Although both are widely used in medical equipment, they serve different purposes. Laser light is primarily used for treatment and surgical procedures, particularly in ophthalmology, dentistry, dermatology, and surgery. Its main advantage is the ability to deliver energy precisely to targeted tissues, making it highly effective for therapeutic applications. In contrast, infralight is mainly used for monitoring and diagnostic purposes. It's commonly found in devices such as pulse oximeters, infrared thermometers, and thermal imaging systems. Unlike laser-based treatments, infrared applications are generally non-invasive and provide safe, continuous monitoring of physiological conditions. Therefore, while laser light focuses on treatment, infralight plays a vital role in diagnosis and patient monitoring. Finally, Table 3 summarizes the main advantages and limitations of laser and infralight in medical applications. Both technologies provide significant benefits to healthcare. However, they also have certain limitations that must be considered. Laser light offers several advantages, including high precision, accurate energy delivery to target tissues, and effectiveness in surgical and therapeutic procedures. However, laser systems are often expensive, require trained personnel to operate, and may cause tissue damage if used improperly. On the other hand, infralight provides non-invasive monitoring, patient comfort, and real-time physiological assessment. Nevertheless, its effectiveness may be limited by its penetration gap in biological tissues and environmental conditions, making it less suitable for precise treatment applications. Therefore, the choice between laser and infrared technologies depends on the specific medical purpose and clinical requirement. This concludes the discussion on the medical applications of laser light and infralight. Next, Abdurrahman will present the conclusion of this study.
And lastly, to conclude our whole presentation is, in conclusion, laser light and infrared light are two significant forms of electromagnetic radiation that possess unique properties and applications. Laser light is characterized by its coherence, monochromaticity, and high precision, making it suitable for various medical procedures such as surgery, ophthalmology, and dermatology. In contrast, infrared light is commonly utilized in thermal imaging, patient monitoring, and diagnostic systems due to its ability to detect and measure heat. Although these technologies differ in their characteristics and functions, both have become essential components of modern medical equipment. Their continued development has improved the effectiveness, safety, and reliability of healthcare services, contributing to better diagnosis, treatment, and patient outcomes. These are our references.